special phenomena. For positrons, it's not important for matter-antimatter symmetry of universe, but it's important for dark matter research because can be some effect. Really, in this space, some effect is seen, is put in evidence. Was already, perhaps we have a signal of neutralino anti-nuclearino interactions or other phenomena. For what concerns AMS2, is the same of Pamela, is experiment, but much bigger because first of all there is a superconducting magnet, so that can reach in principle the energy higher than Pamela. It's not true because Pamela is more precise tracker, but something and what is very big in acceptance, so that can do a special research for antinuclei with a sensitivity at least 10 times than Pamela. This is just this. But what is important, perhaps, is to understand how is born from historical point of view this kind of research. I must this is okay, the best spectrometer that I will, as I said, I will jump. I will go to the 70s. In the 70s...
Piero, I'm sorry. Are you going to tell us the recent results of Pamela?
Sorry?
Pamela, recent results of Pamela. Are you going
recent results, I have 2 slides that I can show at the end, I suppose, the best that I can do. But if I go through, it's less not 5 minutes, but perhaps another single after the 50 minutes. So I think that for the auditorium is much more important this kind of history of physics, really history of physics. In the 70s, the NASA began to study a permanent presence in space. It was possible to put very big things in orbit. People already reached the moon several times with several expeditions and so on. So it was decided to put in a space station in space and some telescopes to see different parts of the electromagnetic spectrum and not all. So where there was a project, the Great Observatory. This happened in the 70s, but they were finally flown in the 90s or more, because very, very long exercise. One was the Compton Gamma Ray Observatory. I said already of this Compton experiment on board of this. The other observatory was for X-rays. In effect, it delayed 10 years and was flown only at the end of the 90s. And the other was for the visible light, or the Hubble telescope you heard about, I suppose, many times. And the other was flown just a few years ago, was the infrared. They should work together to give a unique image of the universe. It was added, sure, something for particle. No, it was the particle. Also was added a very long base interferometry that was realized in the United States to see the radio part. As you know, the atmosphere is transparent a little bit in the visible and transparent in the radio waves. So it's not necessary to put in orbit the enormous telescope for the radio waves. For what concerns the particle, it was projected, it realized the Explorer, Advanced Cosmic Explorer, Composition Explorer, for cosmic rays. This was for low energy because it was small. Why it was small? It was small because it was put very, very far away from the Earth, because the Earth, as you know, we have a magnetic field. Magnetic field is protection against cosmic rays. We are alive here because the cosmic rays are reduced by the magnetic field. Otherwise, we have a flux that the life cannot be eliminated. So this is a problem. When we wish to measure cosmic rays, we must go very, very far away, and at least 10 radius of the Earth, because we must arrive to the micro Gauss. We have 1 Gauss about on the Earth, 0.305. So we must go very far away. And this explorer was constructed, sent in orbit in 95 or like so, I don't remember the date. And the Finally, for what concerns the cosmic rays we are speaking about now for Antimatter, there was a project, also beginning of construction, a facility that was finally called Astromag, with a big superconducting magnet. Several experiments that were alternating on this facility. This facility could not flow alone, was more than 10 tons on the facility itself. It had to be put on the space station. At time, the space station was international or Central American, was called the Freedom, and it was this kind of shape. This facility had to be put in this space station. But as you know, there was a dramatic factor. In the first of all, the shot exploded, which was a stop of several years oil flight in the space. Also, the Russia, they could not more flight as before because there was not enough money. So what happened was finally that this was never constructed. And I finish with this. And on board of this facility, several experiments were projected. One of these experiments was Wizard, dedicated to particle, antiparticle. And then now, from the collaboration, decided to stop the research and to produce, to come in Russia, to produce a collaboration with Italy and Russia, and also the others collaborator, but mainly is Italian and Russian collaboration. It was formed these Russian-Italian missions. So I wish to say two words because we are in Russia. It was a heritage of Wizard. This a lot of activity was around this. There were several balloon flights always on the item of Antimatter. There was also the Pamela, that is experiment I said for continue this research at high energy. A lot of time actually, 10 years to construct to flow Pamela. In the meantime, we had the possibility to do a lot of experiments in life sciences, solar physics, different on the Mir or different satellites. And okay, I will not go through Pamela to describe. Sorry, this is too many. Okay, a beautiful experiment with okay, the positron and antiproton in 3 decades measured. And okay, we see in orbit. There are a lot of beautiful images to see. And finally, in antiproton-proton ratio, are preliminary, but this is what was obtained, very, very precise, up to 100 GeV. These are the old measurements, and what the result is that all is okay with secondary production. That is the result. For what concerns the positrons, normally is measured the ratio between positron and the positron plus antiproton, and plus electrons, and this ratio is measured by several groups. And in past time balloon flight, we saw already these points that are more than secondary production that can be calculated. And if this is due to neutralino annihilation, we have this kind of shape. If we have a pulsar contribution, we should find this other, and so on. And Pamela should say something about in this zone. No, I must say, F also in the 2000 there are these results that so this positron could be originated by source of cosmic rays very near to our point of observation, so inside the galaxy, and the result of Pamela as these ones. There are new points now, something going up deep. So now there is some recitation of this difference, that there really is a huge difference, but a factor 3 on what we foresee. All is a preliminary, but this research is going on. This experiment will flow for another 2 years, and we have other statistics. Okay, these are other beautiful things, but